Here you are going to learn about one of the important nuclear reactions called nuclear fission reaction. You may have already learnt about nuclear fission reaction in 10th standard, but now you are in a little bit higher level. Still we are going to learn more about the nuclear fission. So here, what is nuclear fission? Fission means splitting up. Which one is going to be split? Here the heavy nucleus 92 uranium 235. This is one of the isotopes of uranium, that is heavy element. Its nucleus is going to be split into two fission fragments. Let us take 92 uranium 235 atom. That atom that is to be bombarded with a slow neutron. So the slow neutron 0n1, that 0n1 is nothing but slow neutron. That one acts as a projectile. That projectile that is to be made to bombard on which one? 92 uranium 235 atom. What will happen? This neutron will be absorbed by this 92 uranium 235 nucleus. So ultimately what will happen? One intermediate unstable atom will be produced. That is nothing but 92 uranium 236. This is highly unstable. It won't be existing for a longer time. Are you clear? After that what will happen? That one will be split into two fission fragments. They are all called fragments. Fragments na pieces na artho. 56 barium 141. This is another element which is created in the fission process, and one more fission fragment is created, that is krypton 36 krypton 91. Here in the suffix they have mentioned the atomic number. At the top the superscript mass number is there. All those values can be found in the flux table. Are you clear? So barium and krypton, these two are called fission fragments. So this one is called projectile. You should know the names of the things. That's why I am writing. This slow neutron is called as, what is this? Projectile. Slow neutron. That one is used as a projectile. This is the heavy element. Is it clear? Uranium is going to be split into two. Are you clear? So this here, its mass is greater compared to neutron. Its mass is greater. This is unstable and highly radioactive, and it is also a heavy element. Are you clear? So this is one of the heavy elements used in the process of fission process. Heavy element. Are you clear? You know all the properties of the participating elements. After that, after getting the fission fragment, these two can be called as fission fragments. Fission fragments. Fission fragments. அதாவது ஃபிஷனில் கிடைக்கிற ரெண்டு பீசஸ், ரெண்டு எலிமெண்ட்ஸ், they are called fission fragments. Apart from this, three neutrons are emitted. Three new neutrons are produced in the nuclear fission process. 1, 2, 3. Combinedly, it can be written as 30N1. Finally, ultimately, in the final step of the reaction, there I have written one plus Q. What is Q? Q is nothing but some amount of energy will be released. The energy released in this process will be tremendous compared to the energy released in the chemical reaction. The energy released in the nuclear fission reaction will be very highly clear. The value of the energy released in the nuclear fission reaction will be very, very high. Are you clear? That is, that one may be around 200 million electron volt. To calculate the 200 million electron volt, a separate problem is there. Are you clear? So I will work out that calculation also in the next video. I will send it. Okay. So the purpose of conducting this entire nuclear fission reaction is to obtain the energy. Are you clear? So the energy can be obtained, is clear, in the nuclear fission process. That is the purpose of conducting this kind of nuclear fission reaction. This is one of the nuclear reactions. Are you clear? This reaction was first performed by whom? Two scientists called Otto Hahn and Strassmann. Are you clear? Don't forget this. So these two scientists are the important persons, is clear. Scientists, they have performed this experiment for the first time. Here, the same nuclear fission reaction that is depicted in the form of a diagram. Let us take the slow neutron. It acts as a projectile. It is made to bombard on the heavy element 92 uranium 235. That is a target. Is it clear? When it bombards on this, what will happen? This neutron will be absorbed by the 92 uranium 235 because of the capture. This is called as capture. Are you clear? So neutron capture. So after the capture of the neutron capture, what happens? This unstable and less, its lifetime is very less. Are you clear? Its stability is very less. That's why this is called unstable. It won't be existing for longer time. Are you clear? So 92 uranium 236 will be formed and it is in the excited state. That's why just to show the excited state, they have drawn the these two lines, is clear, just to indicate the excitation of the instability of the nucleus. After that, what will happen? This nucleus of 92 uranium 236 is slowly tried to split into two parts. So this is the intermediate stage. So in this intermediate stage, you can see a shape like a liquid drop. If a single liquid drop, if it is split into two droplets, before attaining the droplets, is clear, this one will attaining a dumbbell shape. Are you clear? Yeah, usually the nuclear fission process that could be explained with the help of liquid drop model. The same thing is drawn here. A single nucleus is going to be split into two fission fragments. So two is clear nuclei are formed. One may be of heavier size and another may be of smaller size. There are several possibilities. Are you clear? Totally 90 types of nuclear fission reactions are possible. This is one of the example to represent to learn the fission process. Are you clear? Not only barium krypton and 3 neutrons, totally 90 type of nuclear fission reactions are possible. Are you clear? In your textbook, one more typical example is also given. So later what happens? From our example, we can say that barium and krypton, these two elements are formed in the fission process. After the splitting, are you clear? Single nuclei is split into two fission fragments. That's why this is called fission, nuclear fission. Are you clear? And then in the same process, how many neutrons are emitted? 3 neutrons are emitted from the process. 3 neutrons are produced in the process. These 3 neutrons, they are main sources. Are you clear for conducting the next successive steps in the nuclear fission process? These 3 neutrons, they will act as a projectile to continue the chain reaction in the case of nuclear fission process. After that, after the entire process over, some amount of energy will be released. That energy, that one may be in the form of heat, that one may be in the form of light, that one may be in the form of sound. On the whole, the total energy release may be this much. Are you clear? 200 million electron volt. This energy can be utilized for destructive purpose and also for constructive purpose. Constructive purpose means the energy what is obtained here that can be converted into the production of electric energy, production of electric power, and also for various purposes. That is the constructive purpose, utility of the energy. So clear. But in the case of atom bomb, the same energy that is used in the form of destructive purpose. Are you clear? All are in our hands. Are you clear? So on the whole, I have explained what happens in the case of nuclear fission process. So the definition will be asked. The definition, the energy released at the end of the fission process, and then the sample reactions, everything will be asked in the examination. Are you clear? Be thorough with all those things. Here, 3 neutrons are emitted. So clear, number wise we are getting 3 neutrons, but on an average 2.5 neutrons are emitted. On an average 2.5 neutrons are emitted per fission process. This question also will be asked in the examination. I hope so clear I have explained everything fully clear related to fission process. Fission means splitting. One heavy nucleus, by bombarding the neutron, it is split into 2 fission fragments and 3 neutrons are emitted. Finally, energy is released. This is a gist of nuclear fission process. Thank you.